Today we're going to continue with section 8.2 and the law of sines. Yesterday we learned that law of sines can be used to solve some triangles that are not right triangles, and that the rule is given as sine of A over A equals sine of B over B equals sine of C over C. Or another way of saying this, the sine of an angle divided by the length of the side that is opposite that angle is always constant in one triangle. There are certain cases where law of sines can be used. What we said yesterday was you have to know one side and angle that are opposite of each other so that you can fill in one of these fractions completely. Here are the cases where this works. Yesterday, you solved triangles where you were given angle side angle or you were given angle angle side. In geometry, those were two ways of proving triangles congruent. So if we're given those parts, there's only one way that the remaining parts can be. Today we're going to look at the side-side angle or angle side-side case, which in geometry was not a way to prove triangles congruent. And what we do today will kind of show you why it didn't work. When you're given side-side angle, so this is two sides and the angle that's not between them, it is possible that there is one triangle, two triangles, or no triangles formed with those parts. So what we're going to do in these notes is look at some examples of each of those cases. In this triangle, we have side A has a length of 2, side C has a length of 1, and angle C has a measure of 50 degrees. I have a 50-degree angle, that's angle C, that's opposite a side with length 1. I have another side A that's length 2, that would be opposite of angle A, and then B would be opposite of angle B. So here, we can use law of sines because we have an angle and a side opposite of each other that we know both values for. I'm going to plug into law of sines, sine of 50 divided by 1 equals, and I'm going to look for what it is that I could find next. The only other value I'm given is the 2. 2 is the length of side A, which is opposite of angle A. So this would be equal to the sine of angle A divided by 2. When we're solving for an angle, we're going to use the inverse trig functions just like we do with right triangles. But first, I need to get the sine of A by itself. So I'm going to multiply each side by 2, and I get 2 times sine of 50 equals the sine of A. If that's what the sine of A is equal to, then A is the inverse sine of that value. Now, when I go and I put that into my calculator, it's going to give me a domain error. The domain error means that this triangle does not exist. This is the case where there is no triangle formed. So if you get an error, that's because there is no triangle. When you do 2 times sine of 50, it's bigger than 1, and sine is always less than 1. Here's a picture of why there is no triangle in this case. Here's my angle of 50 degrees with a length of 2 next to it, and then the opposite of the 50 is the length of 1. If I try to put these pieces and build a triangle, we can see that there's no way for this length of 1 to hit this other side where the 50 degrees is. So there's no triangle possible with those parts. Here's our next example. Again, we're given angle side side. We have an angle of 40 degrees. We'll put it anywhere that's A. That's opposite a side of length 3. I have a side of length 2. That's side B, so opposite of that is angle B. And then I would have side C and angle C. So here's my angle and side that are opposite of each other that I can plug in first. I have the length of 2. The angle opposite of that is B. So I'm going to find angle B first. We multiply both sides by 2. And then again, if that's what the sine of B equals, then what I'll put in my calculator to find B is the inverse sine of all of that. And try to put it in one step so that you're not rounding, or make sure that you use a value that's not rounded when you do this. When you go to your calculator, the value for this angle is 49. No, sorry. The value for that angle is 25.37. So we have a triangle where A is 40 and B is 25.37. And then we could go and find angle C. So C would be 114.63. And then once you find angle C, you can use law of sines, now that we have this angle, and obviously I'm not drawing a scale, to find side C. Sine of 40 over 3 equals sine of 114.63 over side C. And you're going to solve this like you did yesterday, and you'll end up with C equals 3 sine of 114.63 divided by sine of 40, and you get that C is about 4.24. So there is one triangle that has all of these values. But in this case, because we found the angle first, the angle B, we have to check, is there a second triangle? The reason for this has to do with inverse sine functions, and what we learned back earlier in the year is that when you push that inverse sine button on your calculator, it is always going to give you an acute angle, an angle between 0 and pi over 2 radians, or 0 and 90 degrees. But it's possible that in some cases there is an obtuse angle that also works. And that obtuse angle would always be the supplement. So after you find the first angle, we're going to check the supplement. The only time you do this is when you're solving for an angle first, and it's that angle you check the supplement of. To find the supplement of 25.37, and you get 154.63. So if there is a second triangle, that angle has to be 154.63. We want to know, is that a possible triangle? Go back and look at what we already knew. We were told that angle A was 40. So I have a triangle where one angle is 40 and one is 154.63, but that doesn't work because that's already more than 180 degrees. So when we say check the supplement, you find the supplement of the angle you found first using law of sines, and then you check if those angles add up to less than 180 so that there could be an angle C. If I use this 154.63, my angle C would be a negative angle, which does not work. So that's the case where there's only one triangle. Guess what? We have a two triangle case. So here's the last example. I have angle A is 35 degrees, and that's opposite of side A, which has a length of 6. We have B is 8, which is opposite of angle B, and then C would be opposite of C. So again, I have an angle and a side opposite of each other, so I'm going to use law of sines. Sine of 35 over 6 equals 8 is the other value I know, and that's opposite of angle B. And I'm going to go through and solve for B. Multiply the 8 over, and then take the inverse sine. So I get B equals the inverse sine of 8 sine 35 divided by 6. So angle B in this triangle is 49.89 degrees. That's the angle B in the first triangle. So we could continue solving for that, the missing parts in that triangle. Once I have B, I can find C, 180 minus 35 minus 49.89. Is 95.11. And then I could find the length of side C by doing sine of 35 over 6 equals sine of 95.11 over C, which would make C equal to 6 sine 95.11 divided by sine 35, which is a length of 10.42. And that makes sense because in this triangle, 95 is the biggest angle, 10.42 would be opposite, that would be the longest side. This is our first triangle. Now we need to check the supplement. And the angle we're checking the supplement of is the one that we calculated first. So we're going to find the supplement of angle B. It's the one that you use the inverse sine to find. So we're going to say, okay, if I take 180 minus 49.89, this angle B would be 130.11. So I have 35, 130.11, that adds up to 165.11. That is a possibility. So this is a second triangle. There's a second triangle where that angle B is 130.11. In that triangle, angle C would be 180 minus 35 minus 130.11. In this triangle, I'm going to call this C2, would be 14.89. That's my angle in this triangle. And then I would need to find the length of side C in that triangle. So sine of 35 over 6 equals sine of 14.89 over C. And I would solve the same way I did over here, only with the 14.89 in it. And what I would get is that in this triangle, length C is 2.69. And in this triangle, angle C was much smaller than all the other angles, so side C must be smaller than the other angles. Here's the picture for why there's two triangles. We had an angle of 35 degrees that was opposite a side of length 6, and then we had this side of 8. We were trying to find the triangle. If I swing this length of 6 around, I see that there's a triangle here where this angle at the top is obtuse, and there's an angle over here where the obtuse angle is down here, and this top angle is very small. The letters on this diagram are slightly different than in my example, but the sides are the same. So there's one triangle with an obtuse angle here, and the other one where that angle is acute. And that's why there's two different cases for this triangle. So the steps are: find the missing angle using law of sines, solve that triangle. Then take the angle that you found using law of sines and check its supplement. If that supplement keeps your angle total under 180, you need to solve for the second triangle. Make sure that you check for the second triangle in the homework today. If you get an error in your calculator when you do inverse sine, that's the no triangle case.